Hi, and welcome to the video on simple random sampling. This is the first sampling method that we're going to learn about, and it's probably one of the most important ones because it's the one that's kind of it's the method that all the other ones are kind of based on. And it's the best sampling method to use when using um, inference techniques that we'll learn later in the year. Okay, so you could pause the video now and read this definition, but or you could just read along with me. So what happens with an SRS is when you choose the sample, every okay, so you have a population. Every size that you pick from that population, so say you're picking 10, every size of 10 has an equal chance of getting chosen. Okay, and that's a little different than everybody has an equal chance. If every sample size has an equal chance of being chosen, then every person has an equal chance of being chosen. But it doesn't actually work the other way. If every single person has an equal chance of being chosen, that doesn't necessarily mean that every combination of people in your sample has an equal chance of getting chosen. And I'll just show you a counter example of why that's true. Okay, I'm going to do this off to the side. This is what the book talks about. Say that you have 100 people, okay? And you have, out of those 100 people, you have 50 girls and you have 50 boys, okay? So what happens here is I need I need 50 people in my sample. You're going to choose 50 people, okay? And you're going to flip a coin. You're going to flip a coin. If it's heads, I'm going to choose the girls. If it's tails, I'm going to choose the boys. Okay? So I go ahead and flip. I flip my coin to choose my sample, and it's heads. Okay? So now my sample consists of 50 girls, and like I said, any other time you ask yourself, when you choose your sample, you ask yourself, is does your sample represent the population? Okay, my population, remember, was 100 people. That was 50 girls and 50 boys. So the answer is no, okay, because I have all girls. Now you ask yourself, let's pick one of these girls. Here, this is one of these girls, okay? And we're going to ask her, what was your chance? What chance did you get? What chance did you have to get picked? And she'll say 50, 50. And now go ask all these people, what was anybody's chance of getting chosen in a sample? Everybody had the same chance. They had a 50-50 chance, 50% chance of getting chosen. So everybody had the same chance, but we chose our sample and it wasn't representative, okay? So what happens here is every chance of 50 doesn't have an equal chance of getting chosen, okay? Because what we really want out of this sample is we want about 25 girls, we want about 25 boys, okay? That actually doesn't happen here. This Okay, every 50 doesn't have a chance of getting picked. Matter of fact, there's no chance a girl or a boy gets picked. So every 50, so you look at it this way. What's the chance of getting 25 girls and 25 boys? What's the possibility of happening using the coin flip method? Well, there's a zero chance. It's impossible. Okay? So everybody doesn't have an equal chance. Okay, so that's important about that. You'll read that in the book. Okay, so next is a sampling frame. A sampling frame is basically just a list of individuals in which a sample is drawn. Okay, so if my population was a school, then the first thing I would do in an SRS is I'd say, okay, well, let me get a list of everybody in that school. Let me get a list of everybody in a population. So now I have a list of names. Okay, that's my sampling frame. It's a list of individuals in which the sample is drawn. Okay, so now let's get to the fun stuff, which is how do we pick an SRS? Okay, so the first thing we want to do is obtain the sampling frame. We want to get a list of individuals to choose from. Okay, the next thing we want to do is we want to assign a number to everyone in our sampling frame, or every subject in our, and I'll just call this SF, in our sampling frame, just to shorten it up. Okay? Now the last part is to use a table or a calculator later to choose individuals from our sampling frame. Here, I just said I was going to do that, didn't I? Okay, so easy enough. Okay, so the only problem there is how to do this with the table. The calculator is pretty simple, but the table. Okay, so I'm going to write the table method using a table. Okay, now you might not get this until I'm going to show you an example on the next page, but you'll see. The number of digits needs to match the size of the sampling frame. Okay, now that makes no sense to you at all. And we usually, you'll see in a second, we usually start with 0. Okay, so let's say we have a sampling frame with 100 people. Okay, so we actually want to start size of the sampling frame. The number of digits needs to match the sampling size. Needs to match the sampling frame. The size of the sampling frame. Okay, so the number of digits, and I'll say sampling frame -1. Sampling frame -1. So notice there's 100 people. So I need to get 100. If there's 100 people, I need to assign 100 digits. Okay, so what I would do here is I'd say from 00 to 99. So every person is going to be assigned a number. Now I do 00 because when you'll see when I enter the table, I can't start from 0 to 99 because you'd run into a problem. Okay, let me just give you a whole bunch of examples, and then you'll just see. The calculator is very obvious how to do that. So let's say there was 60 people on my sampling frame. Okay, so what you would do is one way you could do it is you could say 00 to 59. Or you could do 01 to 60. You could do either method there. Okay? Okay, let's say there are a sampling frame. Let's say there are 1,000 people in my sampling frame. Now I want to go one less than my sampling frame. This is kind of an asterisk. You just have to practice and see how to do it, and you'll see it. Okay? Because there's two methods to do this, and you'll see which one would be easier. But if it was me, I would say 0, 0, 0. So there's 4 digits in my sampling frame, so I'm going to go 3 digits. 2, 9, 9, 9. Okay? Because what happens is there's 1,000 digits here, because I'm starting at 0, 0, 0, going all the way to 99. There's actually 1,000 digits there. See, I could do this. 0, 0, 0, 1 to 1,000 digits. There's 1,000 digits there, but there's a problem because when you enter the table, okay, you could get, there's a lot of digits you could get that don't count because you would have to omit, which I need to write here. You want to omit repeats and numbers not in the sampling frame. Not in the sampling frame. Because look, if you go to a table, what numbers could happen? I could get 0, 0, 0, 0, okay? And I also could get 1, 0, 0, 1 all the way to 9, 9, 9, 9. Okay? So if you choose this method, you'd have to omit all these numbers. Well, if I choose this method, I don't have to omit any numbers. Okay, there's no other numbers that could happen with 3 digits if I have 1,000 people. Okay, so using the calculator, I'll show you the method. Okay, so it's you go to math, arrow over to probability, and we want to do random int. Okay, and I'm going to do an example of this, but random int, this will be the start, so it would be like 1. This would be the last person in your sampling frame, and this would be the sample size. Okay, so all you'd have to do is omit repeats in this case. You don't have to omit numbers that aren't on your frame, because you're going to name it your frame. This would be the start of the frame and the end of the frame. Omit repeats. Okay, so here, using the table, you have to omit repeats and numbers not in your sample frame. For the table, okay, I'm sorry, for the calculator, you just omit repeats. Okay, so let's show you an example of what a table would look like and how to choose. So let's say we have, let's do 100 in our sampling frame. We have 100 people in our sampling frame. Okay, so I've obtained it. I have a list of names. I have a list of names. So everybody gets a name. Okay, so we want to assign numbers to the subjects. Okay, numbers to the subjects. So if I have 100 people, I'll show you the difference. Okay, we'll do it both methods. So we'll say 00 to 99. This is the good method. Okay, and we have 100. We want to pick 5. We want to pick 5. So my sample size is going to be 5. Okay, so enter. Let's enter line 3. Enter line 3. And I just randomly picked a number. They'll tell you what number to enter, or I'll tell you what number to enter, or I'll give you my own table with random digits. Okay, so if I enter line 3, I want to pick the first 5 2-digit numbers. See, this is 2 digits. This is 2 digits. 2 digits. Okay, if I enter line 3, so who's the first one to get picked? 03. So whoever was named 03, that's that one right there. Next is 27. So whoever was 27. The next comes all the way to the next one, which is 24. The next one here would be 12. See, I use that 2 and the 4. 12. So whoever is 12. And 30. So this would be the subjects that had these numbers would be my sample. Okay. Now, I didn't have any repeats. Okay. So if you had, so like I said, if 3 happened again, then you would say omit 3. Okay. Or 3 was omitted. Now let's see what happens when I do it the other way. This would be the longer way. So if you have 0, 0, 1, 2, 100. There's 100 digits here. So there's 100, I'm sorry, there's 100 numbers, not digits. There's only 3 digits. So this is 3 digits. 100 numbers. Okay, so who do we need to omit? Okay, let's enter line 15. Okay, so I'm entering this line right here. Okay, and I'm looking for 3-digit numbers. Look at the first number. The first number comes up at 764. Okay, well look it. These are the only people that have numbers. So he becomes an omit. Okay, so that's gone. The next one is 888. He's an omit. Now obviously you can kind of see what happens. 889. He's an omit. So I've already went through 3 numbers, 4 numbers, omit, 9, 15. I already went through 5 numbers and I've met them all, because there's a lot more possibilities that aren't there. I only have 100 people, but I have, okay, these 100 people, okay, there's still like 901 chances that there's 901 other possibilities. Okay, because you also have 000 that could happen. Okay, well, 900. All right, let me see, 1,000. Yeah, there's only 100. I'm sorry, I'm thinking 1,000. So there's Let me make sure I'm doing this right. Yeah, that's right. There's all those possibilities. 900 more possibilities. Okay, let's get one that's there. I'm just going to breeze through these quick. That's 915. 860 is a no. Here's one that's good. 073. Okay, so he goes into our sample. He goes to our sample. Okay, because that was this one right here. Look at this one. 701. No. 343. 184. Here's the next one. 041. They goes to our sample. Now you can see what a pain this is, because you could just keep on picking and picking. They goes to our sample, and you'd continue until you get 5. Okay, so the best way to do it is let me just run through these. So let's say you had 1,000 people, so it'd be 000 to 999. You see, there's 1,000 digits. I'm sorry, 1,000 numbers. Let's say you had like this is my sampling frame. Let me just give you some more examples. Let's say you had like 15,742. This is my sampling frame. That's how many names are on my list. Okay, so the way I would number this is I'd always go start at one less than however many I had. Let's make sure. 0, 0, 0, 0. I guess I have to start off with that many. And I'm going to go to one less than whatever this is, whatever number that is. 5, 7, 4, 1. Let's see if that makes sense. Even though there's 5 digits here. Okay, the only time you want to go one less is if you fall right on that hundreds, that thousands, 10,000s, 100,000s, like that. So let's see if this makes sense. Okay, there's 5 digits here, and there's 5 digits here. So that has to match. The number of digits to start with and end with always have to match. Okay, now the question is do I have this many numbers in here to here? Yes, that's true. Okay, because from 1 to this number you have 15,742. If I count back to 0 and I don't make this a 1, if I don't make that a 1, then I'll have that many numbers. Okay. All right, so I hope you get the idea of this. We will be doing more of this in class. You have to be comfortable at doing both ways. Okay, so here I'm going to show you the calculator way. And my calculator disappeared. I don't know where he went. Let's try to pull him up. There he is right there. Okay, so the way you do it on the calculator, it's it's pretty simple. One more time. Thought I had him all the way up front. Okay, so let's say there was 100 in our sampling frame, and we want to pick 10. So we assign the numbers. Now in this case, you don't have to do any of that funny stuff. You don't have to do 0, 0, 0. You just say, okay, 1 to 100. Okay, because the calculator's a little smarter. Okay, we don't want to pick 100. We want to pick 10. Let's pick 10. Okay, so this is how you do it. We want to go to math. Okay, and you see the probability off to the right. So you arrow over to probability. Now we want to go to random, randint. That's short for random integer. Random integer, enter. Okay, we want to go random int, and then put in our sampling frame information. 1 is the start of our sampling frame. 1. We want to go all the way to 100. So this is a start, this is an end, and this is how many you want. This is your sample size. We always call that n, sample size n. Okay, so 1, comma, 100, comma, 10. Now you just have to beware of, you have to be really careful of repeats. Okay, so 95, come on down, 91, come on down, 15, 52, 41, 1, 2, 3, and then just arrow over. Okay, 74, 5, 34, 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, and one more, 21. Okay, no repeats. So this would be everybody that was assigned these numbers makes up my sample. So it's actually a little bit easier to do the calculator way, but you have to be comfortable doing the other way because on the AP exam or on any exam, they could always give you a table of random digits. So that's the only example I'll do with the calculator. We'll be doing much more in class. So thanks for watching.